Alright, last video we were talking about the different names of the different algorithms for computing a derivative. And we went through the power rule, and we discussed what happens when you have a polynomial and you want to take a derivative of it. I definitely recommend checking that video out because these algorithms build on one another. So you need to know the power rule in order to properly use the product and quotient rule. And in the next video, we'll talk about the chain rule, but right now we're focusing on the product and quotient rule. So when we talk about a product is an operation of two things multiplying together. And so let's write ourselves a few functions. We'll call one f of x, and let's say it's equal to 2x squared plus 5. And then let's give ourselves a function g of x, which is equal to x cubed. Alright, so now we're going to invent a new function. Let's call it h of x. And h of x is going to be equal to the product of f of x and g of x. So h of x equals f of x times g of x. Well, now the question is, how do I handle this? One way is you can actually just distribute g of x into f of x. And that'll work great here because we have two polynomials multiplying together. But later on when we start learning methods of deriving trig functions and other odd things like that, you really won't be able to make it easier. But anything using polynomials can be reduced down to the power rule. Although it's sometimes a waste of time, and you should just stick with the product rule. So the product rule says that if I want to take the derivative with respect to x of h of x, so shorthand that's h prime of x. So what I'm looking to do is I'm looking to take the derivative with respect to x of f of x times g of x. And so how I'm going to do that is a cool saying that I've been using since I learned this myself. And the saying is this. It goes, first d second. What do I mean by first d second? I mean the first function, f of x, times d second, which is the derivative of g of x, or g prime of x, plus second d first. So g of x times f prime of x. Alright, so we got first d second plus second d first. D standing for derivative, first standing for the leftmost one and the rightmost one. It doesn't matter though, because this is an additive property, these can be reversed and it won't make a difference. So you could say second d first plus first d second. I just like to say first d second plus second d first. It's how I've been saying it for a while. But in this case, order doesn't matter for the product rule. We'll find that it does matter for the quotient rule. So all I really need to do here now is I need to figure out what f of x is. Well, I already know that. I need to figure out what g of x is. I know that. Now all I need to do is figure out what the derivative with respect to x of g of x is, g prime of x. So let's go ahead and calculate g prime of x using the power rule. So g prime of x is the derivative with respect to x of x cubed. Using the power rule, we'll bring down the 3 and subtract 1 from the power. So g prime of x is 3x squared. How about f prime of x? This one's a little bit longer, but it is a polynomial. So we can apply linearity and take the derivative of this one with respect to x plus the derivative of that one with respect to x. Well, the derivative of 2x squared, we bring down the 2. That gives us a 4x. And we're left with a 1 in the power. So 4x to the first, just 4x. And the derivative of a constant is 0. So the 5 goes away. And now that we have our g prime of x and our f prime of x, as well as our f of x and g of x, we can now plug it in to the product rule to find our derivative of h of x which is the product of f of x and g of x. So we plug in things where they go. The first thing's f of x, 2x squared plus 5 times g prime of x. G prime of x is down here, it's 3x squared plus g of x, which is x cubed, times f prime of x, which is 4x. And so right there we've solved for h of x. We've solved for the derivative of h of x, where h is a product of two sub-functions. Alright, next we're going to take a look at the quotient rule. And you may ask yourself, if we have a product rule, why do we even need a quotient rule? Because a product is just an inverse quotient, and a quotient is just an inverse product. So in other words, dividing is only multiplying by the reciprocal. And so why do we need a quotient rule? Well, the quotient rule isn't necessary. You can actually fool your way through any derivative simply using the product rule, because once again, a quotient is just an inverse product. But the nice thing is sometimes you'll notice the quotient rule works a little bit better with the problem that you have. So let's go ahead and take a look at the quotient rule. So I showed you an example on how to solve the product rule. The quotient rule is very similar to the product rule. If you have some function h of x, which is made up of a divisor, g of x, that's dividing out of the function f of x. So in other words, we've got h of x is equal to a fraction of f of x over g of x. And let's invent our f of x and g of x again. Let's say f of x equals x cubed, and g of x equals 2x to the 4. Alright, so that would mean that h of x is equal to f of x cubed over g of x, 2x to the 4. Now you may look at this and say, well, you could just simplify this, and you absolutely could, and just use the power rule. However, once we start getting into trigonometric derivatives, you're going to want to know these. So just pretend like you can't algebraically simplify this for now, so that you can learn the process. So in the quotient rule, so the product rule was first d second plus second d first. The quotient rule is low d high minus high d low all over low squared. And that's the saying that I use, low d high minus high d low all over low squared. And what I mean by that is I mean whichever one's lowest, that would be g of x, times the derivative of the high. Well, the higher function is f of x, and the derivative of that with respect to x is f prime of x, minus high, which is f of x, d low, which is the derivative of g of x, g prime of x, all over low squared. That's g of x squared. And so this is our format. Just like for the product rule, we have a format here. And this is equal to the derivative of h with respect to x, which is h prime of x. Alright, so let's finish up this problem. So the derivative of f of x here, using the power rule, f prime of x is equal to, we bring down the 3 to the front and multiply it with any constants. In this case, it's just a 1, and we subtract 1 from the power. For g of x, g prime of x, we do the same thing. We use the power rule. We bring down the 4, multiply it by any constants up front, which there's 2. 2 times 4 is 8. X to the 4 minus 1 is 3. And now we just plug it in. So h prime of x is is equal to g of x, which is 2x to the 4 times f prime of x, which is 3x squared, minus f of x cubed, times g prime of x, is 8x cubed, all over g of x squared, 2x to the 4th squared. And of course this simplifies, but it's really more important that we just know the process of using these rules. You will get to simplify a lot of these algebraically, but it's really important just to learn these algorithms first. And so right there we've got the product and the quotient rule. I just want to point out that these are literally just algorithms that were discovered. The definition of a derivative comes down to that limit problem that we discussed in the last video. But these are going to save us a lot of time and a lot of limits. Limits can be very difficult, so we're grateful for these rules. I'll see you next video where we'll be talking about the chain rule.